Forming a neighbor relationship. So I've mentioned several times in my videos that for those routing protocols that do form a neighbor relationship, they have to exchange some information first, make sure certain things match, and then they can talk to each other. Then they can exchange routes. Well, that's what we're going to look at right here. So if you and I are two routers and we're speaking EIGRP, very first thing we're going to do is we're going to send each other EIGRP hello packets going to 224.0.0.10. Remember those K values I just talked about? Look right there. We have to be the same. Our K values have to be identical. Now, as long as you don't touch them, you don't have to worry about. They all have default values. They will always be the same. Where this can be a problem is imagine a network that's got a lot of routers. Let's say 200 routers in a really huge enterprise network. And the network administrators say, okay, well, for most of these routers, because I know most of these routers are only considering bandwidth and delay, that's fine. But these routers here in the middle, in the core of my network, I actually would like them to use load and reliability as well, because I know EIGRP has the capability of using those in its formula. So for those routers in the middle, I'm going to go to their K values that apply against load and reliability that right now are 0, and I'm going to change those K values to something else, like 1 or 2. So now load and reliability will be factored into the formula. Here's the problem with that. If they change the K values just on these routers will be able to talk to each other. They will be able to form neighbor relationships, but they will now lose their neighbor relationships with all the other routers around them because their K values are mismatched. They're not matching. So the moral of the story is try not to change the K values. Very few people need to, but if you have a burning desire to factor in load and reliability into your formula, you'll have to change the K values on every single router in your organization because they all have to match. So keep that in mind. The source IP subnet. So these EIGRP packets are contained in an IP header. So when I send you an EIGRP packet and I send it to 224.0.0.10, I'm going to use my source IP address as the source, obviously. So let's say that there was some misconfiguration between the two of us, and I was 1111 and you were 11.11.11.11. Somebody mistyped the IP address. Well, when you got my EIGRP hello packet, you'd say, uh-oh, there's a problem here. This guy is directly connected to me, but his source IP address is not in my subnet. This guy is saying he's 11.11.11.11, but I am 1 dot something. We're not in the same subnet, so we would not talk to each other. As a matter of fact, as a network administrator, what you would see is you would actually see every few seconds a syslog message pop up that gets very irritating because it pops up again and again and again. It says, neighbor not on common subnet. So if you ever see that message, neighbor not on common subnet, you should say, IP addressing problem. Two routers are directly connected, but their IP addresses do not fall in the same IP subnet. Somebody made a mistake. So the source IP subnet has to be identical. And the autonomous system value. So if you recall from earlier videos, an autonomous system is simply a collection of networks, doesn't say how big or how small it is, a collection of networks that's all managed by one administrative authority. So for example, at your company, you probably have an IT department that manages all the networks in your company. So technically, that network in your company is an autonomous system. Now, let's say that your company had no need to connect to the internet. I know, highly unlikely, but let's just assume that for a minute. So the only reason you have a network in your company is so that you can talk in your company. You can reach your own email servers. You've got your own web servers, but you're your own self-contained island. You're not going to talk to the outside world. All right. So you need to run some sort of interior gateway routing protocol in your company so your routers can learn of everything. Some interior gateway protocols like RIP and like OSPF, they don't even care what autonomous system number they're in. They just assume that, hey, if I hear from another RIP router, RIP is an IGP, therefore that guy must be in the same autonomous system as me. Or in the case of OSPF, oh, I just got an OSPF hello from somebody. Well, OSPF is an interior gateway routing protocol, so I'm just going to assume he's trustworthy and he's in the same autonomous system as me. EIGRP is not like that. EIGRP, even though it is an interior gateway protocol, actually has to verify that the person it's talking to is in the same autonomous system. As a matter of fact, within the body of the EIGRP hello packet, there's a field that says, what autonomous system number am I? So as part of your configuration for EIGRP, you actually tell it the autonomous system number. Now, most of the time, that number can be whatever you want as long as it's the same on all the routers. Because your EIGRP routing protocol most likely is not going to be talking to any other companies or any service providers. It's not designed to talk outside of your autonomous system. It's designed to operate within your autonomous system. And since you maintain and control that autonomous system, you get to pick the number that you want it to be. So you could have it be EIGRP 100, 200, 9. The main thing is all the routers have to have the same EIGRP autonomous system number because they are including that inside their EIGRP packets. And if it's mismatched, they will not form a neighbor relationship. What's actually kind of irritating is that if it's mismatched, you don't even see anything. In other words, no syslog messages will pop up. If you try turning on some debugs, you'll see nothing. It's just sort of like invisibly and silently discarded if the AS numbers are mismatched. And then also the hello and hold time don't need to match. So within the EIGRP hello packet, when I send it to you, I will actually tell you hold time. In other words, I'll say, okay, if you don't hear from me within 90 seconds, then you can declare me dead. I'll actually put that in my hello packet. You have the ability, if you want to send me your hello packet saying, great, Keith, thanks. However, if you don't hear from me within 300 seconds, declare me dead. That's perfectly fine. Our hello and our hold intervals don't have to match. As long as we know what they are, and they will be in the hello packet, we know what they are, that's perfectly fine. That's well and good. By comparison, OSPF is not like that. When we get to OSPF, you'll see that the hello and what they call the dead interval do have to match in OSPF, but not in EIGRP. And the last thing I want to talk about here in this video is passive interface. I don't know if I talked about passive interface. I think I did in my videos on RIP, but just in case I didn't, or in case it's been a while since you've studied that. So under your routing protocol, so let's just do EIGRP. So here's your first snapshot of how to configure EIGRP. So at the global configuration level, you are going to type router EIGRP, and then you're going to put your autonomous system number. I'll just use the number 7 as an example. So all my routers will need that. And then I have to put some network statements. So that's going to put me in a new mode, config-router mode. And now I'm going to put some network statements. So let's say here's my router down here. And this is fast Ethernet 0. This is fast Ethernet 1. And this has 1111/24. That's my IP address. And this is 2222/24. Okay, well, I want OSPF to be activated on these two interfaces, and I want to advertise to neighbors those directly connected networks. So I would go under my router EIGRP, and I would say network 1.000 and network 2.000. All right, and now my router, speaking EIGRP, will start sending out EIGRP hello packets this way and this way. I say, well, hold on a second. In my topology, actually, there's another router right here. So yeah, I do need EIGRP speaking on fast Ethernet 0, but on fast Ethernet 1, that's just connected to a switch, that has a bunch of laptops and PCs and servers on it. I really don't need to send out EIGRP hellos this way. As a matter of fact, I'd rather not, because if there's somebody with their PC here and they're using Wireshark or Ethereal or something to capture packets, now they're going to see my hellos and they're going to find out, oh, the router's running EIGRP. I now know what the K values are, and I now know what the autonomous system value is. Maybe I don't want people sitting in the cubes to know that. So I say, oh, okay, I don't want it sending out hellos on this interface right here. But if I remove my network 2 statements, if I get rid of that, network 2000, now he's not going to speak on that interface, which is good. That's what I wanted. But also, I've taken away his ability to advertise this network to this other router. So, what do I do? Well, this is where you use the passive interface command. Passive-interface. Sorry for my sloppy writing. And then in my particular case, I would say fast Ethernet 1. So when you use the passive interface command, that says this interface is not allowed to transmit any EIGRP packets, including EIGRP hellos. So no hellos will be going out this way, which is exactly what I wanted. What do you think would happen if I also typed passive interface fast Ethernet 0? Well, that would be a problem, because then hello packets would not be allowed out fast Ethernet 0. And if there's no hello packets going out here, this router has no reason to form a neighbor relationship with me. If he doesn't get hello packets with me, he's not going to have a neighbor relationship. And if he doesn't have a neighbor relationship with me, he's not going to send me any routes. And I'm not going to send him any routes. So be careful where you use passive interface, because if there actually is a router on this interface, you've just now killed your ability to form a neighbor relationship with that router, because you are no longer sending or receiving EIGRP packets. Even if an EIGRP hello packet comes in, you're going to drop it, because that interface has just been made passive.